Take it to the limit one more time. Take it to the limit one more time. Excuse me. Hey, what's up, homies? I made a limit video, and the first part of this is going to review what we did talk about in class. So I'll try to go through this part pretty quick because most everybody did that. Some of you guys might have missed class, so this is that worksheet from last Thursday. So we haven't had a lot to do here in the last 6 days. I'll try to ramp that up for you guys. They ask you to plot this graph on a calculator, on your grapher, this function f of x, and when you do that, you get this dot 0, 5 is the y-intercept, and then you got what does it go down? I already forgot. 2, 1, 0. That's kind of funny. Go away. Does that show up in the video, I wonder? And then it's a parabola. So something I don't know that I stressed in each of the periods, but I meant to. I know I didn't in one of them. Might have been first. This equation doesn't say x squared, right? It's x cubed minus x squared all over x minus 3. It's what we would formally call a rational function. It's a fraction, so it's rational. Like a rational number is a fraction, like 1/2 is a rational number, 2 is a whole number, right? 2 is also a rational number because you can make it 2 over 1, so then it's a fraction. Anyway, Marty, hurry up. This is going to take too long. You know my videos are always too long. But what's happening here is this is a parabola that's missing a point. This point right here doesn't exist for this graph. It's a hole in the graph. And so I know some of you guys were already watched this lesson and you're like, okay, Cork, you already told us. So we get down to some of the words down here and notice they're still there from second period when I wrote them yesterday. I was wanting to have this video made yesterday after second period, and then I don't know, a whole bunch of other things happened. Oh, yesterday was a day of meetings. Man, it was busy. I had second period, and then I had a PLC meeting with Miss Ellis, which is like our pre-calculus group. Then we had sixth period, and then we had a faculty meeting with Miss Kaylin. And each of these meetings lasted about an hour, you know? And so it was like 4 hours of my whole day was like sitting on Google Meets. So I didn't make this video yesterday, I'm making it now. When you plug 3 into the function at the top, you get 0 over 0. That's what it's asking you in question 2. 0 over 0 has a name called indeterminate form, as it says in the objective at the top of the screen, right? Finding a limit at an indeterminate form, okay? And so the graph at an indeterminate form has a hole. The fancy math word for a hole in the graph is a removable discontinuity, okay? So in this case, the y value at this hole in the graph is the limit of the function as x approaches 3, right? So as I get closer and closer and closer to 3, right, on the x, y is getting closer and closer and closer to what? Y is getting closer and closer and closer to 2, okay, on the y. So this is how we ask the limit questions, as we write LIM for limit. X approaches some number, like in this case 3, as you see down here in box 3, or in question 3, of f of x. The answer is 2. Okay, so for the most part, the rest of the problems that you're going to have, they're going to ask about limit as x approaches a number for some function. Okay, the limit, in case you're wondering, I don't know what limits are. A limit is a y value. The limit is the y value. Okay, whatever the y value is, that's the limit. So the limit is the y value. Sometimes the y value exists. Like if I asked you, what is the limit as x approaches 2 of f of x? The 2 is here. 2 has a dot at it, or there is a, the function's defined at 2. It's not defined at 3. 3, there's a hole. 3 is not in the domain of the function, but 2 is. So what's the limit as I get closer and closer and closer to 2? Arbitrarily close to 2, the limit is 1. 1 is the limit, okay? So you can have limits at places where the graph exists, okay? You can have places, you can have limits when the graph doesn't have a hole, okay? Those are the best kind of questions. Because see, f of 2 is 1, right? That is the point, 2 comma 1, right? There's a point, 2 comma 1 on this graph. But if I ask you, what is f of 3? F of 3 equals, huh? Or row raggy, or it equals, can't do it, right? I don't know, IDK. We can also use the 3 letters D and E for does not exist. That's what gets used the most often. If like it doesn't exist, we just say it's not there. You can say it's not possible. You could say 3 is not on the domain, if you want to church it up. But I can have a limit at any question on this entire graph. I could ask you, what's the limit as x approaches 5? What's the limit as x approaches 7? What's the limit as x approaches -5? What's the limit as x approaches -7, right? Why do those two numbers come into my head? I don't know. But they're going to ask questions about the limits at the holes in the graph because that's when it's more complicated, right? So what does it mean to find a limit? It means to get closer and closer and closer to that number. In this case, on problem 3, when x is 3. So you're not actually looking at 3. You're looking at 2.99999. And you're also wanting to look at 3.0001. You want to look at both sides of the 3. I'm gonna bring this back up. So I'm getting closer and closer to 3 like this, right? I'm gonna get closer and closer and closer to 3, right? I'm looking closer and closer to 3. Both sides of 3. Both. Look, I got my shag-em-up going today. Shag-em-up, Marty. So cool. We did that for homework. You're like, dude, we already did this. Can you hurry up? The answer for question 4 was basically make a table using these x values. And what you can notice in the table is that the limit at 3 appears to be 2, right? It appears that these numbers in y are approaching 2. From the left side, right, I approach 2 because 1.8 is close to 2. From the right side, I'm approaching 2 because 2.2 is getting closer to 2. So this concept of left and right, I'm going to talk a little bit more about today, okay? This was a graph that we did in class on Friday for 4th period. Let me hear your 4th period. Whoop, whoop. All right, on Monday, we did this in 1st period. Let me hear you 1st period. Whoop, whoop. And then we did this on Tuesday with 2nd period. Let me hear you 2nd period. Whoop, whoop. That's right. That's going to be very exciting when we start the year next year and my 3 pre-calculus classes all get shuffled into, hopefully 2 BC calculus classes. And then we bring in together a whole new group of fun, right? So again, I had done these answers already, but if you didn't see the class last time, if you didn't do the Google Meet, I thought maybe you could try to do some of this here on your own. If you want, you can even try these on your own before I write the answers up, okay? Like I'll pause the video right now and work them out. And then once you think you know what they are, then unpause it and see, watch me talk through this. So again, question A, what is the limit as x approaches 3 of f of x? This is the function f of x. Notice this is a very crazy piecewise function. This graph consists of more than one piece. There's a linear piece, there's a dot, that's a piece, and then there's this like kind of cubic looking function. I don't know, maybe it's a quartic function. It's some polynomial looking function. Or maybe you're thinking it's a part of like a sine curve. I don't know that it is because this arrow means it keeps going down. So I didn't intend for it to be a sine curve. But this is my function f of x, okay? And I want to find the limit as x approaches 3. Notice 3 is right here. So as I get closer and closer and closer to 3, just like I did on the last graph, what is the y value? The limit is what y is getting closest to. As x gets close to 3, what is y getting close to? So as I do like boop, 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 on the x, you got a boop, 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 on the y. And that y value, in this case, is 0. I got to undo all my boop, 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 0. Okay. What's the limit as x approaches 4? Okay, so 4. I'm boop, 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 on 4. Boop, 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 boop. I'm getting closer and closer and closer to 4. What is the limit is the y value. It's the y value at this discontinuity, like it says on the worksheet right above. Okay, you run the video back and go back above. The y value at this discontinuity is the limit of the function as x approaches 4 in this case. Okay, so in this case, this function kind of different than the last one. Because see, the last one, it had a hole in it, but we did not define the function to exist at 3. This graph is different. It has a hole in it, but the hole, like it floated away, right? Like it just, I think in one of the classes used analogies like a piece of gum, it spits it up and it gets stuck on the ceiling, right? So the dot is like the value of the function. That's actually question F. We could jump down here real quick. What is the function's value? What does y equal when x is 4, y equals 3? What is the limit of the function as x approaches 4? Okay, the limit is 1, right? The limit is 1. If I jump down to question I, f of 3 is 0. This is the function's value at 3. When x is 3, what does y equal? Y happens to equal 0. Whoops. And the limit also happens to equal 0. So right now, look at this in this example. You can see there's 2 zeros, and then there's a 1 and a 3. The 2 zeros match. They go together, right? They seem to like be the same thing. The limit's value and the function's value are the same number at 3. And I happen to say this, I think, in second period, but not in the other classes. This is technically our definition of being continuous. And I'll write this down another time, but just to say it, in mathematics, we would say, well, a function's continuous if I can draw it, right, without having to lift my pencil, right? It's continuous curve, it keeps going. But if I have a break in it, I have to lift my pencil and go across. See, there's a break here. Oh, look, there's a break there, okay? So mathematically, to write that something is continuous, the definition is that the function's value and the limit at that same x value are the same number. If the function at 3 and the limit at 3 are the same number, then that means the function is continuous at 3. And if you look, the graph, it has like normalness going on, right? It's normal. But at 4, something's not normal. See, at 4, the function's value is one answer, but the limit as I approach 4 is a different answer. That means my graph cannot be continuous. And when you look at it, you can tell it's broken, right? There's a gap. So f of 8, or I jumped to g for some reason. What is f of 8? Go to 8. Right here, f of 8 is the dot right there. It looks like it's 5. Right? Did I pick the right dot? Yeah. I'm going to tilt my thing up. What's the limit as x approaches 8? As x approaches 8, it's also 5. Because see, as I get closer and closer and closer to 8, as x gets closer to 8, what is y getting closer and closer to? Y is getting closer and closer and closer to the same thing, that 5. Right? So don't look at 8, look at 7.99999. At 7.99999, I'm so extremely close to 8 that I'm basically at 8. And what is the y value there? The y value is 5. So again, like our definition before, this function is continuous at 8 because the limit at 8 and the function's value at 8 are the same number. So my function's continuous at 8. So that's fun, huh? What's the limit as x approaches -3? All right, something exciting is happening at -3. I don't know what happened to my little tick marks though. I must have erased them. I didn't write them back in there. Boom, boom, -3 is right here. Okay, so this is different and crazy. Okay, we haven't had this happen yet. Except unless you came to class before and you're like, yeah, Corp, we already did this once. Would you please hurry up? Again, you can kind of skip ahead in the video if you've already heard all this and you get it. But what's the limit as x approaches -3? So this is tricky Because as I approach -3 from the left, right? From the left, correct? From the left. Undo, 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 undo. Read it. As I approach -3 from the left side, I'm actually up here on this piece, which is the linear piece, the line. And what's the limit as I approach -3? That line is coming down here to 2. Okay. What's the limit as I approach -3 on the other side of it, right? The other side of it, we would talk about the right side of -3. On the right side, you're on a different piece. Notice the limit there is 1. So what's happening here is like, boop, 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 boop. I don't have a removable discontinuity. Okay, this is what's called a, you guessed it, non-removable discontinuity. At a non-removable discontinuity, the limit does not exist. Okay, cool. This is the first time this has happened, right? In Mean Girls, remember, the limit does not exist. And what was happening there was a vertical asymptote, which we're going to see in a minute. But here I have a different kind of non-removable discontinuity. There's no asymptote here, right? There's no like dot 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 like dotted line. The graph usually goes like towards an asymptote. But you'll wait to see the next example. There's an asymptote. So if your graph on the left side and on the right side are different, then they have to be the same number. And there's more notes on that coming next. What's the limit as x approaches 0? Notice 0 is here, 0. And I just picked this because it didn't hit the square on the corner. So I just thought it'd be fun to guess. Looks like it's about -0.5. You might argue, no, it's more like -0.55 or -0.59 or -0.47. Anyway. What's f at -3? What is the function's value at -3? I know there's a hole at -3, but it also contains a dot. Okay? The dot lives at 1. And what's f at -6? Well, I just put it on the line. So 4, 5, -6 is here. That's right there. It's 6. So being able to read a graph, that's a huge part of AP Calculus. Okay, believe it or not. There's always graph questions on AP Calculus, and we will get to doing other questions from graphs, like what is the slope at this number, or what is the integral at this number, and we can do all of that with graphs. So that's coming down the line. This is like the first few steps of that. So what I hadn't talked about yet, because this worksheet that I gave you at the top, it doesn't need it, but when it comes to limits, there's a very, very super duper major important concept, and there's a super duper major important like bit of notation. I think I'm going to zoom out 20. Whoa, not that much. And I've been using these words a little bit, but I need to make it like formally written down. And so I can talk through this forever, or we can just say, no, Court, go faster. We can pause the video here while we write this down. So before you pause the video, I'll read everything, but still. A limit from the left and a limit from the right. We just did that on the last problem at -3. Remember, we had to look at -3 and we're like, on the left side of -3, the graph comes down to 2. On the right side of -3, the graph goes up to 1. So there's actually a slightly, adjusted notation here. And it's kind of weird. Probably never seen a number written, this way. And what's backwards about it is it kind of looks like I'm using an exponent. But it's more of a symbol than an exponent. It's not a power. This means 2 from the left side of 2. Maybe a way to think of it is like 2 with a little minus sign after it means take a little bit away, right? Like I want to take 2 and make it a little less. I'm going to subtract a little bit from it. So if you have 2 with a little minus sign, that means we're on the left of 2, right? Because left is like less than 2. And when you minus a little bit, you go less than 2. So what is the limit as x approaches 2 from the left? Notice this is not -2. It's still a +2. How do you know it's a +2? Because it's a +2. Oh, wait. I don't know if those show up when I do this. I'll have to go back and watch the video. I keep getting these pop-ups from Facebook on my screen, and I don't know if they show up in the video or not. It's kind of funny. What's the limit as x approaches 2 from the right side? You use a little plus, because a plus sign means more, right? You want to go a little bit past 2. Not a lot, just a little, like 2.00001. okay? That means 2 from the right. What if you have the limit as x approaches 2? See how there's no symbol here at all. There's no plus and there's no minus. Well, that's every single question that we've done already, right? That means I'm going to approach both sides. As I approach 2 from both sides. How's this already been 20 minutes? Isn't that crazy? 20 minutes? So this is what we've been doing, this very last part. We've been doing this already. And in order for that answer to exist, the limit on the left and the limit on the right have to be the same answer. They must equal each other. They must be the same. So we'll go through some examples next, and maybe the examples will sort of make sense of this. But any one of these could be a question all by itself, okay? So far we've only been asking like one version of a limit question. Now it turns out there's like 3 different flavors of a limit question, okay? But as it turns out, whenever you do the limit as x approaches 2, you're automatically going to do these other 2, right? So like the one problem at the bottom would mean you have to do the top 2 anyway, because you have to check the left and the right to see if both sides agree with each other. The limit has to agree with each other on the left and right, or it doesn't exist. So if you need to take more time to write the notes, you can pause it. Like a bear walks into a bar and he's like, hey buddy, I'll have a beer. And the bartender's like, okay, sure, but what's with the big paws? And the bear goes, I'm a bear. I got big paws. Get it? Okay, so these are the jokes. All right, let's do this. Notice I did not put an asymptote on this example. It's the next one. So you see there's an asymptote coming up. So here I just thought I would do a practice of left and right. So here's a new graph. Down here in the very corner here, you have the origin 0, 0. So this is just the positive x-axis and the positive y-axis. And this graph only lives right now, is only graphed in the first quadrant, right? So what's the limit as x approaches 2 from the left? Part A, question A. As I approach 2 from the left, I should pick a different color since I put my graph. Let's pick blue, since I put my graph in red. Here's 2. What's the limit as I approach 2 from the left? So the left side of 2 would mean 1.5, 1.7, 1.9, 1.99999999999. So as I get closer and closer and closer to 2 from the left side, see how these blue dots are showing up? I'm approaching 2 on the left side. The graph is going to 3, right? I end up at, I need to undo all of that. I end up at 3. I put a lot of dots. Martin, really? Okay. So as I get closer and closer and closer to 2, what is my y value? Remember, going back to the worksheet, question 3, the y value at this place is the limit of f of x as x approaches, in this case, 2. Now, I know on that worksheet that you had last week, it says the y value at this discontinuity. There isn't a discontinuity here. This graph is connected at 2, and that's fine, okay? It's fine for it to be connected. So what's the answer as x approaches 2 from the left? It's 3. What's the answer as x approaches 2 from the right? Again, the right side means a little bit more than 2. So a little bit more than 2 means I'm coming down the line to that y value. And what is that y value? It's 3. Undo, 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 undo. So question C is, what's the limit as I approach 2 from both sides? When there is no plus or minus, it means both sides. In order to answer question 3, you're going to answer part A and part B first. And look, we already did part A and part B first. You're welcome. So what is the limit as x approaches 2 from both sides? If A and B are the same number, then C is that same answer. It can't be anything different. Okay? So the limit from the left, the limit from the right equals the limit from both sides. Part D, E, and F. Notice this is 4 from the left and the right and both. And 4 looks like there's something a little bit more magical happening, if you consider, divisiveness magical. It's broken at 4, right? It's separated, okay? This is a piecewise function. I kind of thought this first piece was like a line, and the second piece was like maybe some part of a parabola, I don't know, maybe. Maybe it's an exponential growth function. I don't know. I don't have an equation for it, so it doesn't matter. But what's the limit as I approach 4 from the left? 4 from the left side. Again, here's 4. the left side would mean doot, 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 or up this line to the y value as I approach 4 from, imagine like being like on an airplane, you know, so like an airplane's like, you know, oh no, Cork, don't draw the picture. Oh, that was terrible too. See, my chair sits really low and my tablet sits higher than, so I can't hardly see. That's my excuse. You know, it's supposed to be an airplane. So there's an airplane flying in, you know, it lands on this runway, and where does it stop? It's going to stop at 5, right? As I approach 4 from the left, get rid of the stupid airplane. As I approach 4 from the left, I'm still undoing, sorry. It's 5. What's the limit as I approach 4 from the right? It's 3. What? Because again, the right side, you're on the other curve. So I'm on a different trajectory, right? I'm on a different path. I'm coming from New York, not LA. You know, so you fly in from LA, you're over here. If you fly in from New York, you're over here. So welcome back to Louisville. So the limit is the y value as I approach 4 from the right. The answer there is 3. Do these two numbers happen to be the same number? Is the limit from the left equal to the limit from the right? No. If they are not equal, then the limit from both sides is D and E. The limit does not exist. Again, you can't have two limits, right? Like if you're driving 55 and you get pulled over and you're like, officer, I was going 55, and the cop's like, yeah, you were going 55, and 55 is the speed limit, but we also have a speed limit of 35. And if I wanted to, I could not give you a ticket because you were going the speed limit of 55. But I'm going to write you a ticket because you were breaking the speed limit of 35. You can't have two different speed limits on the same place, right? You know, if your mom tells you to be home at 10 o'clock and your dad says be home at, 5 o'clock p.m., your mom says 10 o'clock p.m., well then, you got two different limits. That's a problem. You got to make sure you iron that out before you leave, or you're going to get in trouble, right? So again, if you need to go back and like think about this, pause the video. I'm going to try to get this done faster. Sorry, I talk too much. That's what I do. I miss you guys. Okay. Here's a whole new graph. Is this the graph with the, no, it's not. Okay. I forgot how many problems I made up. Example 4. Again, these problems are kind of tough because you don't have them in front of you on a worksheet. You're looking at a video, and you can try to write them in your notes, draw them just kind of haphazardly. If you want, you can pause the video and answer all these questions. What's kind of quirky here that we haven't talked about yet is I did put in an asymptote. And for whatever reason, I made the X and Y axes blue, and I started drawing the graph in red. And usually I do my asymptotes in red, but I was like, well, let's just make asymptotes yellow. So there's a vertical asymptote here at the Y axis, which is X equals 0. So you notice the first few questions that I asked you are, what's the limit as X approaches 0? And this first one is X approaches 0 from the left. So something kind of quirky happens now. This is kind of fun. I'm approaching 0 from the left. And as I come in from the left side, the graph goes up and up and up forever, right? So what is the name that we have for the number forever? It's just forever. That would be infinity, okay? What about part B? The limit as X approaches 0 from the right side. The right side of 0, right? You're at 0.5, you're at 0.1, you're at 0.01, you're at 0.00001. You're approaching 0 on the right of 0. And notice there, the graph is going down, 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 down forever. So there's infinity and there's also negative infinity. Are kind of the more preferred answers when there's an asymptote, as long as you can state infinity or negative infinity. Because what happens when you go to part C? Notice part C is X approaches 0 from which side of 0? Which side of 0? That's both sides of 0, right? Both sides of 0, undo, sorry. Both sides of 0 are not in agreement with each other. I just had a thought. Sorry, my brain stopped me from talking. From negative infinity to positive infinity, you have two different things, right? This is like not the same answer, okay? So technically we must say part C, the answer is D and E. okay? Because the left side and the right side do not agree with each other. Now, an argument could be made for all three of these answers to be D and E, okay? And this is where you kind of get into some technicalities. Think about what it means to be infinity. Infinity is the complete opposite of a limit, right? A limit means you like can't go any further, or you are going to stop at this value, right? It's as far as you can reach. That is my limit. I can't reach across, to my neighbor's house over there. It's too far, right? So infinity is completely breaking the limit. Infinity goes on forever and ever and ever and ever. So some people may say, well, I put D and E for all of these, D and E, D and E, D and E. And that's okay. That's not wrong. When it comes to the AP exam calculus test, if they can ever state infinity or negative infinity, they will. Okay, so that's something to be mindful of. Like if this were a multiple choice question, you could very easily have a multiple choice question like this on the AP calculus test. They would put infinity or negative infinity as the answer most likely. For part A, the answer would be infinity. Now, they would not also have as a multiple choice option D and E. You're not going to have D and E and infinity. You wouldn't have them both, but it's just something worth mentioning that the answer to all three is technically D and E. But if you can be more descriptive about why it's D and E, you can say infinity, negative infinity, right? It's kind of like, will you go to prom with me? And she's like, no. Well, that's just like not going to happen. D and E doesn't exist. You don't have a date. But if she says no because I don't like your car and your hair is ugly, then you kind of have a more descriptive reason as to why she's not going, right? You know that you need to buy a new car and cut your hair, or comb it. Okay, so infinity is like a more descriptive answer for D and E. All right, that's been enough on that. So whenever there's asymptotes, you're going to have one of those three answers. Those are the asymptote answers. When it's a vertical asymptote, infinity, negative infinity. What's the limit as x approaches 2 from the right? As x approaches 2 from the right, you have 1, 2. Look, it's right here. It's 1. If you want, I'll just rip through these quick. Matter of fact, why don't you just pause the video right now? I'm going to put up the answers. You can unpause it and come back and check them. Okay? Mark, set, go. Pause. As long as x approaches 2. Well, that's both sides of 2. Both sides of 2 are still 1. Because it's the left and the right side of 2. 2 is here. It's 1. Okay? What's the limit as I approach negative 2 from the right? Negative 2 from the right is over here. I'm at 1. I better undo that. What's the limit as I approach negative 2 from the left? From the left, negative 2 from the left, are at this like horizontal, like constant function, which goes up to 4. So the left side is 4, the right side is 1. Question H is what's the limit from both sides? From both sides, the answer is D and E. Because the left and the right do not agree with each other. The left and the right do not agree with each other. In order for H to have an answer, F and G have to have the same number, the same answer. Okay. In order to answer question H, you are going to figure out F and G first. So if question F and question G were not here, like if I never asked those, but I did ask H, you would have to do F and G anyway, right? Because you have to check the left and check the right and see if they're the same. What's the limit as I approach 1 from the left? So 1 is here, and the left side, I'm down on this piece, right? The left side of 1 is like 0.9, 0.99, 0.999, and that would be negative 1. Boop, bip, bip, negative 1. What's the limit as I approach 1 from the right side? That's 2. I didn't ask a question here because I kind of wanted to keep it symmetrical with 5 and 5. What's the limit as I approach 1 from both sides? I can just put that over here. The limit as x approaches 1. That means both sides. Because there's no little minus and no little plus, it means both sides, which has to be what? Everybody say it. D, N, E. Oi, oi, oi. D, N, E. Okay. What's happening in this graph is there are 3 different types of non-removable discontinuities. This is a non-removable. The asymptote is a non-removable, and then at 1, there's a non-removable discontinuity. So there's 3 times where this function has a limit that does not exist. And you see there's 3 answers there on A through K. A through K have 3 answers that are D and E. Okay. Non-removable discontinuities is when you get the limit does not exist. What's happening in Mean Girls is there's an asymptote on the board behind Erin's head. And when she's asked the question at the end of the the quiz bowl at the end of the movie, she says, what was on the board behind Aaron's head? And when she says something is like, if the limit does not approach anything, then the limit does not exist. That's what she kind of whispers to herself. I think I don't have it exactly, and that's what's happening in an asymptote. If the graph is not approaching anything, then it goes up forever, down forever. The limit does not exist. Okay, cool. So I made up one more, and I'm going to stop talking, and I'm going to let you just answer all of these questions. Okay. I'm never going to stop talking. Notice what I did sneak in here was a couple f of x questions. Okay, so maybe just to practice one of those. What is f of 1? F of 1 is the function's value at 1. So when you look at 1, notice there's a hole and there's a dot. What is f of 1? That would be the y value when x is 1. And the y value when x is 1 is 10, because that's where the dot is, right? It's the y value when x is 1. It's 10. Okay, so now questions A, B, and C are going to ask you about the limit as x approaches 1 from the left and right. And what I just realized a second ago was I was going to just show you the answers real quick. So at this point, you're going to pause it, and I'm going to scroll down to the answers. Okay, so pause it and work them out, and then pause it. Okay, no, pause it here, work out the questions, then unpause it and check your answers. Okay, so pause it now. And look, there they are. I was worried that I didn't work them out. I was like, did I work out those answers? That was the brain fart I had earlier. Okay, now unpause it. I don't know if you can hear me say unpause it, because if it's paused and you're working out the answers, then you're like, when do I unpause it? Shoot, you're never going to hear me. Right? If I read, unpause it. So if I did it loud enough, maybe you could hear me say that. Okay. These are the answers. I think I got them all right, hopefully. What I'm going to do now is I'm going to put up a worksheet on Google Classroom. You can try to answer it, and then we'll keep on working. Okay? Sounds like fun, doesn't it? I'm going to stop now. Go back and pause the answers if you need to check them again. I'll catch you pre-cows later. White Reaper!